Hello again, and welcome to another Trilobite 093 tutorial video. This is the second in our three-part introductory series, and in this session, I'll show you the basics of building patches using our visual patch editor for creating both instruments and effects. I'll use the standalone version of Trilobite running on a Macintosh computer, but everything I show you will work for the Windows and plugin versions as well. Note that I'm assuming you've already watched the first tutorial video, and won't be reviewing basic main window interface features. For the most part, this tutorial is intended to get you started with the basics and won't be an exhaustive explanation of all the editing features. The Trilobite user guide is provided for that purpose. Okay, let's go. Once I've launched Trilobite, I'll start with a brand new empty mod synth panel by clicking the Add Panel button up here. Like I said earlier, every Trilobite patch, in order to make sound, must have an output module. So let's add that first. I right-click in the empty background of the patch renderer window, select the Insert Module submenu, select Output up here at the very top, and Trilobite plops a new output module right there. That's kind of right in the middle, isn't it? No problem, I can just left-click and drag the module over here to the left. Signal output will keep popping up as long as your mouse hovers over the module. I'd like to say that's a feature, but it's actually kind of a bug. Oh well. What to do next? I know, let's do something from my favorite genre, a dubstep wobble bass. Superficially, the typical design for this instrument is done by passing a harmonically rich bass sound through a low-pass filter, and then sweeping the cutoff frequency of that filter to achieve the wobble effect. So that's what we'll do. We'll start by creating our bass sound using some sine wave oscillators. I add each oscillator the same way I did the output module, using the right-click pop-up menu, sliding down to the Insert Module submenu, and then selecting Oscillator. There it is, and then another one. I can left-click on these modules and drag them around to put them where I want. There's going to be more plumbing in here, so I'll put them over towards the right side. As we covered in the last tutorial video, the single input port to an oscillator module controls its frequency. I'd like to control the frequency of these two oscillators with a single parameter, and to do this, I'll need to make sure that they receive their frequency value from the same place. To achieve this, I can use a sum module as a single signal source. Just so you know, for the rest of this video, I'll explain each editing operation in detail the first time or two that I do it, and then start moving a little faster to keep the pace of this video flowing along. Now I want to route the output from the sum module into both oscillator modules. To make a connection in the Trilobite editor, you always left-click on the output port of the source module, drag to the input port of the destination module, and release. There it is, a new connection. I'll repeat for the other oscillator. Note that a module output port can flare out as many input ports as you want. To control both oscillators from a single parameter, let's map parameter 0 to the first sum module input port. To do this, right-click on the module port, select the Set Input Parameter Map, which makes a floating combo box appear. Select parameter 0 from this combo. Now I'll spread my fingers on the Macbook mouse to zoom in, and then left-click in the background editing canvas to drag the sum module over here where we can see it, and show you the mapped parameter value. While we're here, I'll drop in a const module as an oscillator frequency control source, like this. We'll need to set the oscillator frequency values to an audible range. I'll do this by double-clicking on the constant module to open its static parameter panel, and then set the frequency value to something in the, shall we say, baritone range. Remember, the mapped parameter will scale this value, so the frequency value we just set is the maximum. I'll press the escape key to make the static parameter panel go away, and then drag on the background again back over to the oscillator modules. I'd like to make this patch even more bassy by dropping one of these by an additional detuned octave. To do this, I right-click on the bottom oscillator's input port and select the Set Input Scalar option. The little text box that pops up allows you to enter a numeric scalar value, so I'll enter 0.51, which sets this oscillator's frequency to approximately half of the top ones, and then press Enter. And there it is, the new scalar value appears just to the right of the oscillator's input port. We need to add the output signals from both of these oscillators together to hear them, so I'll insert another sum module and hook it up. You already saw this once, but I didn't comment on it. Note that when I connect the last open input port on a sum module, it pops out another one. I'll hook up the second oscillator. Let me use a pinch gesture to zoom back out where I can see the whole patch. Now, we want to be able to hear what we have so far. To do this, I connect the summed oscillator signal, here from the sum module I just added, to the input port 0 of the output module, and then press the play button down here in the corner to hear the sound. Let's hide the editor window for a moment and try the mapped parameter. Here's the parameter we just mapped, which lets me adjust the bass frequency. Not a lot to this yet, but we still need to add our wobble filter. Let's bring back the editor window by clicking here, and restore it to full size. We'll use a biquad module for our low-pass wobble filter, so let me just find one in here. To make this a low-pass filter, I double-click on the module to open the static parameters panel and select low-pass as the filter type. Then I want to send the mixed oscillator signals to the input port of the biquad. That's the input port on the bottom. To get that wobble sound we really want, I'll use another oscillator module with the frequency driven by a const. The low-pass cutoff frequency is what we'll be sweeping, so I'm going to use the oscillator I just added as the LFO which sweeps it. The biquad input port for the cutoff is this top one, even though it's labeled center frequency. Let's hook it up. The input frequency to the LFO we just created will control the wobble rate, and this is something we'll want to parameter map for expressive effect. I'm just going to guess that we want our wobble to work in a range from very slow sweep all the way up to almost audible frequencies. So I'll set a scalar value on the oscillator input port to be 20, which gives us a parametrically swept range of 0 to 20 Hz. To control the wobble rate, I'll map parameter 1 to it. For the sweeping cutoff frequency, you'll get your best results by sweeping across a large portion of the audible frequency spectrum, and the output from the oscillator modules always has an amplitude limit of 1. To remedy this, we'll scale the biquad center frequency input, in this case actually the cutoff frequency input, to a big number, like 10,000. We can get some really cool effects by changing the cutoff frequency, so I'll control it using parameter 2. We need to set the filter Q value to an interesting value, as one more means of changing the character of the sound. And to do this, I can reuse the const module I just added by splitting its output. Q will give some subtle effects over a range of about 0 to 2, where 0 squeezes the filter output so tight it's almost like an oscillator. Then I'll map parameter 3 to it. Let's get rid of the temporary connection I made earlier to hear the unfiltered oscillator mix. To do this, I right-click on the input port of the connection and select Delete Connection. Then I connect up the biquad module output to the port I just opened up. Let me show you another way to do that, and also demonstrate Trilobite's undo option while I'm at it. To undo my last editing actions, I can right-click in the canvas background and select Undo from the pop-up menu. And then again. Instead of deleting the prior connection first, I can just overwrite it with a new connection. I'd really like to try this out now, but for best effect, I'll MIDI map all of the parameters first. I really prefer turning knobs to mousing a slider. I'll go through this process pretty fast, so if you want more explanation, please pause this video and watch our basic features introductory tutorial first. Okay, let's try this out. Not too bad, but let's modify the recipe just slightly and increase the harmonic richness of our source oscillators. By default, a Trilobite oscillator outputs a sinusoidal signal when first loaded. let's open the static parameter panels for these guys, and change one of them to a square wave, and the other to a sawtooth. That's better. Now that I've created my patch, I'd like to personalize it by adding some custom metadata that lets other users know where it came from, how to use it, who I am, and so on. Trilobite lets you add metadata information to your patch either in the bank manager or in the patch editor. In this video, I'll demonstrate the patch editor feature. To view your patch metadata in the patch editor, click this button. Trilobite metadata has 3 text fields: the title, author, and description. To enter data in each of these text fields, double-click on it and type. This is just a scripted tutorial video, so I'm going to make some stuff up here. In addition to metadata text fields, you can also set a metadata image for your patch. To do this, just double-click on this little no image icon, and then use the file browser to select an image you would like to attach to your patch. There, now all shall know that this is my patch. That's all the actual patch editing I'm going to show in this video, but before I go, let me show you how to save your work. Trilobite gives you several ways to save, but I'll show just the recommended practice of saving your patches in banks. It's really quite easy. Just click on the patch thumbnail of your newly created patch and drag it to an empty patch socket of any bank of your choice, like this. Once you've added your patch to a bank, it's saved to your disk immediately. Make sure to save it again if you make any further changes. I've only covered a small subset of the patch editing features available in Trilobite, so I urge you to check out the Trilobite user guide for more details and access to more advanced features. Thanks to all of you for hanging out with this tutorial. I realize it was a long one. If I glossed over any particular patch editing detail that you still don't understand after reviewing the user guide, please post a note on the support forum at Darwin Arts and we'll get back to you as soon as we can. In our next tutorial, I, or my illustrious counterpart, will take the Wobble base patch we just created and use Trilobite's evolution engine features to create a whole new population of sounds. I realize that this will be the tutorial that many of you have been waiting for, so stay tuned. If you would be so kind, please leave us your feedback in the YouTube comments section below, or post a note on the support forum at the Darwin Arts website. Keep making those weird sounds.